All right.
Go ahead.
I'm going to go over what we've been doing for logs and analytics and stuff here at Comcast. Basically, kind of what we've done, what we're building, and what we're hoping to try to release to everybody eventually. So when we first started the project, this was basically what we were looking like for data. Nearly 20 terabytes a day of new raw data logs and everything. That's not counting like all the indexes themselves within Splunk and all of that. This is basically the raw logs generated out of ATS, traffic router, traffic monitor, and a little thing that Brennan might be talking about, which is the Conmon net stats information as well. So we kind of had to go down a route of how can we deal with all this data at a very extreme scale and be able to scale as we continuously grow even beyond that. Because as you can see, most of this data is clear back from June, and we've since probably grown that by at least 50%. So what have we built so far? So instead of doing the normal traditional elk stack that everybody's used to, we went down a route of using Spark with some custom code instead of Logstash, but still leveraging Filebeat and that to pick it up, get it into Kafka, get it shipped around between all the data centers, and get it into some central aggregation points so we can load it up into Elasticsearch. God, that looks ugly on here. Basically, this is kind of what we're looking like now and into the future a little bit. Filebeat grabbing it, traffic logs, moving it around. And I'll go over what traffic logs is here in a second, but basically funnel it through, turning those raw tab or space delimited, key value delimited log files that are being kicked out of all over traffic control into the JSON and stuff that Elasticsearch prefers. So what is traffic logs? This is kind of the heart of everything, and this is really what's running in the Spark cluster and what it's doing. You can basically think of it as Logstash. It leverages, instead of that custom query like construct language Logstash uses, this is just using YAML. And it's broken up into two components. One of them is pipeline definitions, and the other is parse tree definitions. That way you can do very complex parsing and transformation and enrichment without having to do a lot more on the pipeline and cloud all your YAML configs and stuff that way. By doing the parse trees, we're actually able to traverse all the logs. Like if you saw some of the examples that were popping up, like the cookies fields and the header fields that are logged, or money trace. A lot of those require sub-parsing and stuff like that, as well as like user agents and IP geolocation, stuff like that. You want to add more to it, as well as expanding upon what server is impacted, what are we talking about there, what delivery service are we interacting with on this request, and all of that added information so you can gain more insight out of your stats as they come through. Right now we've written it just to pull stuff from Kafka, but we do currently have endpoints that are feeding right into our Elasticsearch cluster, as well as Kafka, and we're currently working on an S3 deployment so that various customers and stuff can get their logs that they request directly so that they can do whatever they choose to do with them, whether that be for their own verification purposes or whatever use case they may have. But along the way, we did have a number of challenges. The first is we went and we were attempting to use Apache Beam. If you're familiar with it, Beam was a abstraction that Google originally started doing to allow you to run your pipelines on various backends, whether that be Spark, the Google Cloud's Dataflow product, Lambda if you were in AWS, or Fiac, or Flick, however you pronounce it, or the other many assortments of Apache pipeline use cases that are out there. But it kind of led to a lot of problems that we had, and we since abandoned that and went straight at the Spark SDKs, mostly because a lot of the stuff around that Beam had support for when it came to managing where are you in Kafka and replaying that and coming back to that from outages or other issues was very unstable. It would break if your like it required HDFS really to even get that to work right. And if you ever had an HDFS issue or corruption in there at all of a sudden your entire pipeline doesn't know where it's at, and trying to pick back up where you're at was another issue. As well as it just didn't have a lot of optimizations for working on top of Spark. So you would have unsatisfactory execution times of each of the micro batches and everything that run through the platform. So originally we set out using this in our internal VM infrastructure, which is OpenStack. And OpenStack uses Ceph as its underlying block storage. And needless to say, we're putting so much data into there, we kind of clogged their pipes, per se. Yeah. We've since worked with the OpenStack crew for now, and they were able to give us what they call their iFlavors, which kind of correlate to the Amazon iFlavors, which are basically VMs with ephemeral disk SSDs. So it kind of gave us a short-term win until we could get actual hardware in. But avoid Ceph if you can, if you ever try. As well as we found a bunch of problems with the Spark to Elasticsearch aspects. Elastic, the company themselves, actually releases a product called Hadoop ES, or ES Hadoop, that provides a bunch of hard integrations into Elasticsearch to pipe data into there at higher speeds and higher concurrencies. They are basically accessing a lot of the underlying undocumented APIs that Elasticsearch has to pipe data into it to do things a little bit faster, as well as they've generally put a lot of optimization into it for a lot of stuff. But as we found, a lot of what we were doing was a lot more data than they originally wrote it for. So we've been doing a bit of work with them on fixing those problems and improving the performance there. And a number of those patches have gone upstream already, as well as just general Elasticsearch funniness that by default that client tries to do. Like every single micro batch after it's done being sent over to Elasticsearch, it would try to ask Elasticsearch to flush it to disk instead of building out bigger segments in memory. So you'd have a lot of performance loss there. But yeah. As well as we had to do a bunch of tuning within Elasticsearch itself. A few of those are like, we got heavy into mapping your types. Elasticsearch really likes that. By default, it tries to treat everything that you send it as a text primitive, and in doing so, it'll try to apply a full text search index on it, as well as a keyword search index on it. Most of the stuff that comes through on the ATS logs in particular is integers, floating point, whatnot there, as well as just general keywords. So there's no need for full text search in those cases. So we did a lot there, as well as leveraging Curator to let us, as data's coming in, keep the replication really low so that you can index really, really quickly and then boost the replication after a certain period of time. So you can get that resilience back and move there. As well as, again, the ephemeral disks that we moved to kind of helped out a ton there. The S3 uploading, we actually had to get a little creative when it came to this. S3 has a few limitations on how they put it, because you can either do a multi-part upload or a single-part upload. But if you do the single part, you have a cap on how big your file can be. That's essentially 5 gigs. Which in a lot of cases, some of these ATS machines are generating 5 gigs worth of logs in no time at all. especially when you take into account all of a cluster generating logs. But as well as the multi-part has a minimum requirement on how big the files are. So we got a little creative and piggybacked on what LZO is capable of doing to achieve this and gain compression on it as well. So LZO letting you do multi-part compression. We can, on each individual executor and CPU core that's in our Spark cluster, we can take all of that data, compress it on that CPU that's hitting that CPU, and then just have the byte stream from there coming off of that and aggregate that to a single point for the actual upload to S3. So we kind of spread the parsing and compression amongst the CPUs and just kind of focus the upload. And that's led to a lot of openings there. Where are we going to go with this? The idea we have is kind of taking not just the concept of what Elasticsearch has given you, which in a lot of people's case, in our case in general, is kind of replacing Splunk and assisting in your day-to-day operations management and issue investigation and whatnot, and expanding upon that to help also provide more in-depth stats on a more timely manner and in a longer data range. So instead of Elasticsearch being kind of limited to only keeping a few days or a month at a time, moving that into potentially Druid and stuff, and I'll cover that a little bit more. But in doing all this, we kind of need some place to orchestrate and make people's lives a lot easier. So we're looking at building a actual UI and stuff that'll become part of this, so you can dig in, see what jobs are running, see where those jobs are at, see that your ATS edge nodes are an hour behind, so you know what your expectations on data are when you're querying and looking around and stuff, as well as just general access point via like SSO or LDAP, whatever auth scheme you need, as well as providing some initial reports that'll be generated and maintained and just kind of be part of the infrastructure as well, and digging more into what are all the knobs you need to know your growth forecasting. Is it how much impact is bringing on another 1,000 set-top boxes going to be? Is this going to require more edges or more mids, or is this going to require more traffic routers, or what's our data volume going to look like coming through all these pipes, as well as what's our bandwidth? If you've ever dealt with actual data centers, you need to know how much bandwidth that data center is going to be inbound and growing those pipes in advance, as well as just general tenant usage and billing aspects and stuff, and allowing you to put arbitrary aggregation information. Because like in the CDNs itself's case with growth forecasting, some people don't have the notion of a set-top box as an aggregation point that represents a customer or a collection of requests, and you grow by that scalar. So letting you put in your own representations there and stuff, as well as on the billing aspects, what are your billing points? Do you just bill on bandwidth? Do you bill on calls to origin? Do you bill on calls to mids? What all those points are, and being able to arbitrarily put that information in there and generate those reports for you. We also found that Filebeat is not the greatest. So we're actually working on building a replacement to it. Preliminary, we're actually seeing a lot better impact on the CPU than Filebeat was doing. So it's nearly 1/5 of its CPU cost that Filebeat was having. We're doing it all in Go. The biggest aspect of why we're doing this is actually moving away from the Surama Kafka client and moving to the librd Kafka client, which is actually a full-blown Confluence supported client, everything. And one of its big factors is it has all of what you've grown used to in the Java realm when dealing with Kafka, where if a broker goes down, you can still write to the brokers that are up. As well as if you're reading, if a partition's unavailable, why can't you read from all the other partitions? librd has all that logic that was always present in Java land, now available in Go land, where Surama kind of faltered. A number of times we had noticed where, like, if a broker was down or offline for any particular reason, the Filebeat would just stop sending data across the wire and back up on the machine. And if that was long enough, you would start losing data. So we did a lot to try to replace that and are working on that currently. But we're also looking in, as I mentioned, Druid. Unlike Elasticsearch, Druid is focused on more of a columnar store and focused on more of a time series database aspects. So think like what you've ever dealt with Influx or those like, but on the able to scale to hundreds of individual machines to perform your queries and searches and data storage. It's also really good at being able to keep data for very long periods of time. So it has this notion of a deep store. So you can archive off data that may not be relevant now, but you may wish to access later. So if you have requirements around like billing aspects and needing to keep those around for a year, stuff like that, you can keep that off store on cheaper hardware like S3 or whatnot like that, as opposed to right on your actual machines that conduct the search that are very expensive. But unlike a lot of the other products on there, Druid's really built for scale and redundancy and high availability. So we're looking at that to supplement on top of Elasticsearch. So Elasticsearch will be kind of more of your ops dashboard. I need to see what's going on now. I need to look at the individual event and kind of do that forensic deep dive, where Druid will be there to provide more of your dashboards, your day-to-day logic, see what's going on, how things are performing, and hopefully be able to catch issues before they become issues. Like being able to graphically see that maybe one of your regions is becoming overloaded and getting a bad route or something like that, or all of a sudden no traffic's going there, and is that expected or not? Because a lot of those times they start off little small trickles and you don't know. But this is basically what the whole pipeline will look like in the future. We'll basically break traffic logs into two portions. One of them just being the aspects of loading data into Elasticsearch. Because outside of Logstash, Elasticsearch doesn't really have a consumer built into it, so you kind of have to push it in. Where Druid actually has the notion of consumption from Kafka or any other various assortment. And we'll basically be reading off Kafka back into Kafka and as actual like Avro or JSON or protobufs back into Kafka, so that both Druid and Elasticsearch and any other platform that you may wish to integrate into this can get access to that nice, clean, fully flushed out data set without having to know how to parse ATS logs and the like. But yeah, that's it. Any questions?
Sure. So do you ingest everything today in Elasticsearch, or?
Right now, we're only ingesting into our little tiny one because it's in OpenStack, and they don't have enough resources for us to consume all of Comcast's data. So we're only working with our syndication side of the house to consume into that and provide them with what they need to do their day-to-day operations. Because in a lot of those cases, we don't have Splunk access or anything like that, so that's our only source.
So what's the size of the index, like daily, or are you using like hourly indexes, or?
I have them being broken down on a day-to-day index basis. The ATS is separated from the traffic router and traffic monitor as individual independent indexes, as well as there's a second index off to the side that everybody reports in, and that's where all of the pipelines and stats information about the pipelines are fed into that as a means of tracking all that. So we don't have another database off to the side to manage.
Okay, I was just like curious about like the size of your charts.
I can pull those up.
Okay.
I didn't put them in there.
I just like to compare them.
But yeah, I believe last I looked, one of the syndication partners was averaging about 200 gigs a day.
Okay.
Doing all this type mapping drastically cut it down. and we are actually indexing compressed. So instead of doing the curation, re-index, and compressing it on the roll, we just wrote right into best compression, basically, so gzip under the covers, and actually saw decent performance, if not gains in areas. So it wasn't that bad as everybody had chalked it up to, because there's a lot of stuff out there that says don't compress it on the initial import and stuff like that. But it actually worked really well for us.
Is there anything that we could do in terms of log formats themselves to make traffic logs job easier?
I mean, the ideal would be it being in an actual good, clean format. But
Actual structured data?
yeah, right now, the fields, what's kicking out of ATS and stuff is arbitrary in nature. Some fields are secondary comma delimited as opposed to keeping with a consistent spaced and equal separator. Like money trace in particular likes to go between equals and semicolons as opposed to the other normal flows. So there's a lot of different layers of parsing to deal with those different issues. That would reduce CPU load, but really at this point, the parsing logic that we've got is actually very, very fast. And we actually spend more time on just getting Elasticsearch to take the data than we do parsing the data and getting it ready to go. So.
So ATS has a number of options in outputting log, I'm sure you're aware.
Yeah, we looked at doing a semi-JSON structure out of it, but since it's not really going through a JSON constructor, you end up running into a lot of the problems we had before and actually had to submit patches into traffic control for, which were unescaped fields. So,
If you like squid, those are an option.
yeah.
Built in, you might be able to run it through a YAML output and have an actual output.
Yeah. So,
Well, that's not just ATS. I mean, that's all the components, right? If
Yeah.
structured logs was a first-class citizen, then that might make life easier in the consumption realm.
yeah, because the consistency would already be off, and basically this first portion we wouldn't have to do. Granted, we'd still have to enrich the data at some point,
Yeah.
because like currently all the information about the tenant and the delivery service and the origin involved in every request is not tracked, and we're having to do crazy header forwarding logic to do so. But
If there were a way to have a clear channel between here is structured log output with clearly defined fields, is without having to go and manipulate the entire chain of data flows, is it something reasonable to assume that if such a thing existed, that could propagate all the way through? So if I add a structured data field of a particular key name, that I could assume that on the far end in Grafana or
So
Ceph
the
or
way-
whatever, it would be
yeah,
available.
so we've actually got that in this way, because the parsers, as long as the structure is known in advance, we can do whatever. So
Okay.
if you want to add one more ATS field on the end, it's just going to pick it up and it's going to appear in Elasticsearch for you. It'll appear as a text object initially until somebody is made aware of it needs to be of a special type of some kind, whether it be a Boolean or an integer or something like that. But it'll show up at least so you have access to that data and it's not lost,
Okay.
as opposed to what we've had before.
But this assumes but this is only for like metric level data. This isn't for general data like the
We can kick
diags.
through whatever wants to be kicked through. So the whole thing's written that it's just like Logstash in nature. If you've got some logs that you want in there, we can apply as much or as little transformation as you want on those logs to get them into Elasticsearch.
We have
The
to get
more
tags and error logs in there for syndication part.
Yeah.
We don't have to.
Okay.
So
Yeah, I just didn't know if unstructured data was something that
No,
could mean
the mo-
sys
the more
logging had the
structured
next
you can
one, right?
add to it, the better off it is. But if it's a field that has just a blob of text in it, Elasticsearch can still handle that as a full text search.
Okay.
So you can do what you need to do there. Again, the parser, you can write, the whole thing's in Java, but you can actually, if this is something consistent, you can actually create a Java raw parser to go through that text in some way looking for keyword terms or
Yeah.
some piece of information that may be of relevance and pull that out as another field value in some way. So you can do field generation off of the data within there.
That's super common with things like URI paths from
Yeah.
certain customers.
Yeah, so like one of the things we do is the user agent. If you look at the Elasticsearch logs, the actual raw user agent is no longer in there anymore unless we don't know anything about it. And it's actually broken down to the family, the operating system, and stuff like that. Because that's really all you care about. You want to know, was it IE or was it some curl call over here, as opposed to this really long, ugly string that doesn't break down.
Which
and
version of
compress very
Gecko
well.
are you using?
Yeah. So,
I'm not sure I see an alerting component. Was any sorts of open source alerting components?
So as we kind of got touched on earlier, we're the Kafka aspects. We're kind of working in Burrow for some of that, for tracking how are the consumers and producers themselves doing, because that's kind of what it does. As well as there's countless influx-based like Telegraph hooks into Elasticsearch and Kafka and whatever component that's out there. A lot of logs coming out of the pipelines themselves are their stats and their performance metrics are currently being stashed into Elasticsearch, but we can put those wherever we want. In our environment, we would probably be prone to putting those in influx as well. We are working on cross-integrating a lot of these into the Op5 flows. We just haven't yet since we've been in OpenStack, and it's been kind of I don't want to wake everybody up all night long because OpenStack isn't. But
So how does notice the S3 on the diagram? How does it
oh, yeah,
on there?
it was there. It was up in the top right, but I think Google decided to pull an old cached version of this file. But basically, we are kicking straight off the raw logs for now. So it'd be kind of coming off this top part, the top traffic logs. We actually feed from there the raw logs. We don't do any enrichment or anything on those. So it's basically what ATS had on the disk. We're currently running regular expressions against the addresses in the requests themselves. So kind of knowing what the source address was as opposed to the origin address, since that disappeared in ATS 7, if I recall. So we don't have all the pictures. We're currently working on doing all the header forwards in to get the delivery service and the tenant and all that information as actually raw values, so we can just look for that actual key instead of guessing via regex.
Well, I guess it doesn't fit my head. My mind, S3 is like a storage thing. It's not optimized for searching.
No, and that's all we're using it
You
for.
must be able to have something that can search
Um, Yeah, so the S3 side of it is not really for us for searching or anything. It's literally a mechanism to hand raw logs off to whichever partner wants them. So like on our wholesale front, their clients want a copy of their logs. So if they ever have a question or they want to validate our stats or anything, they can if they want. And they're going to do something similar to this, just instead of pulling off the raw machine, they're going to go to those S3 buckets, pull it, do whatever MapReduce processing they want on there to generate those stats and answer their questions. So if they ever have any discrepancy on billing or something like that, they can go do that themselves.
terms of, are there any features like thoughts where you have compression of older logs for safe size and to increase speed of searches over a long period of time?
A little bit, not as much. Unless you're willing to pay for influx, you kind of miss out on a lot of the fun that it can do. And that's kind of why I'm pushing to Druid, because most of all the fun in Druid is free. It's out there, it's open, the whole thing's open sourced. If it's not there, you can go do it yourself. So, and I know I've been talking with Jan and stuff about also the potential of another product called ClickHouse, which kind of a little less complex than Druid to set up. It's more of a like Elasticsearch to set up. Just from what I can find out, it doesn't seem like it can scale to as much data as Druid can. So there's kind of a trade-off boundary there. If you're dealing with little data sets, little CDN stuff, then ClickHouse is probably more in tune for that purpose. So we may make it so both Druid and ClickHouse are options for you and your CDN to choose what you want. So.
I haven't heard you like kind of how this as a replacement for Splunk. What do you see as a purpose? It's been in, how it goes together. Maybe take care of something.
Basic idea is once you have everything in Elasticsearch, what your value add from Splunk is now gone. Splunk's value add is just, it's simple. You plug and play, gets it there, but you pay for it. This aspect is just being, here's the same equivalent, but as a open sourced product that's out there. So it's, you basically your front cost is your hardware cost and network costs, and that's it, as opposed to a licensing cost, which you still also have to pay in Splunk's realm too, since you have to buy your own hardware there too.
Also cheap.
Yeah.
Thank you.